In this video, we're going to finish the notes on absolute value inequality. So this is the second page of your blank notes from the hockey page. Part A of the practice, to start solving this inequality, we need to get absolute value by itself. So I'm going to subtract 5 first. And I have to do that first because absolute value is not by itself. Now I'm ready to make my two separate inequalities. So I can drop the bars at this point. The first inequality is going to stay less than 19. The second inequality inside the absolute value stays the same, but I'm going to make the symbol greater than, and then 19 becomes negative 19. Now to solve for P here, I simply have to add 9 in both cases. So 19 plus 9 is going to be 28. P is less than 28. And then the second one is going to be adding 9. Again, P is going to be greater than negative 10. So this is a less than case. If we go back to the first video, less than case is always going to have that sandwiched piece in between the two endpoints. So if I thought about this number line, here's 0, here's negative 10, here's positive 28. To be less than 28 but greater than negative 10 is going to be everything in between. And again, this does not have an equals to, so these are going to be open dots. And then everything in between would be shaded. If I'm writing this as an inequality, it's going to be P is between negative 10 and 28, or parentheses negative 10 to 28. And let's check that in Desmos real quick. Remember that P needs to become X when we type this in. So negative 9 plus X, and then plus 5 is less than 24. Now we're going to have to zoom out a little bit because we know that these numbers are bigger in this example. Okay, so I'm going to zoom in on this left-hand side just to verify that that is negative 10. We can see it there. And then zoom in on the right side, we have 28, and those dotted lines means that we are not including those endpoints. So our answer appears to be correct. Second example, we need to isolate absolute value first. So we need to get rid of this positive 2 by subtracting 2 from both sides. So I'm going to have 7 minus X in the bars is less than or equal to positive 10. I'm going to make my two inequalities from here. So they both start with 7 minus X. One is going to be less than or equal to 10. The other one's going to be greater than or equal to negative 10. Alright, next step is going to be, I need to get rid of this 7, so I'm going to subtract 7 from both sides. Negative X is less than or equal to positive 3. And then negative X is greater than or equal to negative 17. Alright, now we have a negative X left. We want the X to be positive, right? So we're going to divide both sides by negative 1. And here is what I was telling you about in that first video. When you divide by a negative number in an inequality, the inequality flips. Alright, so watch what happens here. X is going to become positive. The inequality is going to flip to be a greater than or equal to. This will be negative 3. This will be X. Flip this will be less than or equal to positive 17. So we are going to look at this on the number line real quick. Here's 0, 17, and negative 3. Now we are including those endpoints. And we're going to be greater than negative 3, but less than 17. So that would be everything in between. So it still satisfies this less than case, but to make that happen, we had to not forget this step of flipping the inequalities. So let's make sure that that happens on Desmos. So 7 minus x, and then plus 2, less than or equal to 12. Press the home button to get me back. So I can see on this left-hand side, I'm at -3, which is what I have plotted on my number line. And then I go out to positive 17. Everything in between is shaded in this example. So we are correct. Let's write our final answer as -3 is less than or equal to x, which is less than or equal to 17. Or I can write that in brackets because we're including those 2 points, and it's just everything in between. I'm going to leave the last example for you guys to try part C, but keep in mind that if it's greater than or equal to, we're going to have those 2 inequalities. And so we'll have 2 intervals where we're not connecting in between. So you will have a union in your interval from there. Now we're going to take a look at some real-life applications of absolute value inequalities. And we call these tolerance word problems. So your setup for these will always be the absolute value of the actual minus the ideal is going to be less than or equal to the tolerance. So example 3, a carpenter is using a lathe to shape the final leg of a handcrafted table. In order for the leg to fit, it needs to be 150 millimeters wide, allowing for a margin of error of 2.5 millimeters. Write an absolute value inequality that models this relationship, and then find the range of widths that the table leg can be. So I'm going to go ahead and set up my absolute value. I will always be less than or equal to in these problems. And then my tolerance would go here. The actual will always be x because we don't know what the actual value is. It could be anything. If we're making a leg of this table, it could be 140 millimeters, it could be 160. We don't know until it's cut. But we do know that our ideal amount is 150. So that would go here. So what we're basically saying is that the actual amount minus the ideal amount, we don't want the absolute value of that value to be any more than the margin of error, which is 2.5. So that's the tolerance. Okay, so this value could be less than 150 or greater than 150. We're thinking about the distance of that value from 150. Now, to solve this, to find the range of widths that the table can be, we would make our 2 inequalities. So this is part of your answer right here. I would go ahead and circle that. But to find the range, we would make our 2 inequalities. X minus 150 is less than or equal to 2.5. X minus 150 is greater than or equal to negative 2.5. And then in both cases, we're adding 150 to get x by itself. So x is going to be less than or equal to 152.5. And then x is going to be greater than or equal to 147.5. So that means that the values for the table need to be between, if we look at our number line, here's 0, here's 152, or 147.5. They're both going to be on the right side of 0 this time, and 152.5. We want it to be greater than 147, but less than 152. And it can also equal those values. So it's going to be everything in this small range right here, where 150 is the ideal, which would be halfway between those 2 values. So I would write that as the range would be between 147.5 millimeters and 152.5 millimeters. You could also write that as an interval notation with brackets. All right, and then example 4, a manufacturer allows a maximum of 18.5 ounces of cereal and a minimum of 16.25 ounces of cereal per box. Write an absolute value inequality that demonstrates the manufacturer's constraints. So we know that the actual amount is x. We don't know what that's going to be. Anything could be plugged in there. Our ideal, we don't know it. We just know our maximum, the amount that can be allowed, and our minimum. So that means we also don't know our tolerance, okay? So really what we're given here is the answer that we found in the last problem, and we're going to have to work backwards to figure out what these two numbers are in the inequality. So I want you to take a minute and pause the video and think about what would be our best route of finding those two numbers. All right, so after you've given yourself a second to think, what we're going to do, hopefully you thought of this yourself, the ideal is going to be halfway between 18.5 and 16.25, okay? So however you thought about finding that halfway point, I'm going to take these two numbers, add them, and divide by 2. So I'm going to find the average. 18.5 plus 16.25, and then divide by 2. And I'm going to type that into Desmos. So I'm going to put parentheses around the 18.5 plus 16.25 because I want that to happen first. And then divide that by 2. I get 17.375. That is the middle number, okay? So between the highest and lowest point. So that's going to be my ideal amount. Now, to find the tolerance, it's just going to be the distance from the middle to either one of these, the max or the min. So what we could do is we could take 18.5 and subtract 17.375, or you can take 17.375 and subtract 16.25. Whichever way you'd rather do it, you should get the same answer either way because this is the middle point of those two values. So I'll just type in that first one, 18.5 minus 17.375, and we get 1.125 for the tolerance. So that is our absolute value inequality that will demonstrate the manufacturer's constraints.